So this is a presentation on what gradient is, how to calculate it, and how to represent it in its various forms. So gradient is just how steep is a slope. That's all it is. Now, in order to do that, you need to take two measurements from a topographic map, which hopefully you know how to do using the contours on a topographic map or spot heights if they're there. To work out gradient, you need to know what the rise is and what the run is. So the rise is just how far up you go in elevation, and the run is just how far you had to go along the landscape. So let's say we've gone to our topographic map and we've worked out that the rise is 140 meters. We've then gone back to our topographic map and we've measured the distance between those 2 points that we're interested in. So we say the run, let's say, just pulling a figure out of the air, is 1,950 meters. Now, there are various ways to present gradient. Some of them are more meaningful than others. So when people talk about gradient, they talk about rise over run. Right? So you would divide 140 by 1,950. Now, when we do that, we get 0.072, rounding up. All right, that's great. What does that mean? It doesn't mean anything. The gradient is 0.072. All right, that's a number, fabulous. But what does it actually mean? The first sort of meaningful way you can present that is as a percentage. Now, a percentage is just that number represented as a percent. So you multiply that by 100, move the decimal place 2 places. So we can then say that that gradient is 7.2%. All right, a 100% gradient is a 45-degree angle. We'll talk about angles, degrees in a minute. Okay, so you can present gradients as percentage, and quite often roads are often presented as a percentage gradient, very steep roads sometimes. Okay, so that's how you present it as a percentage. All right, is that meaningful? I don't know. The other way to do it is as a ratio. Now, a ratio is 1 as to something. We'll call that x. That means how many meters up do you go per x meters along? All right. So we know if we've got our rise of 140 and our run of 1,950, that ratio would be 140 as to 1,950. Okay. Well, again, that's sort of not all that. It's kind of meaningful because you can now picture that in your head. That for every 1,950 meters you go along, you go up 140. But there's a better way of doing that. There's a simpler way, and that's where we use the ratio of 1 as to something. So how do we convert this ratio of 140 as to 1,950 to 1 as to something? Well, if you can remember back to your junior school maths, probably, you just, to get 1 on the left-hand side, how would you get 1 on the left-hand side? You divide that by 140. So something divided by itself is 1. But to make sure that the equation, the ratio, stays the same, you then have to divide 1,950 by 140. And to get that, go to your calculator, and the answer is 13.9. So that means that for every 13.9 meters you walk, you're going up 1 meter. Okay, all right. Perhaps that's useful as well. The other way to do it is to present it as degrees. Now, if you're really, well, I was going to say really clever, but not really clever. If you can remember back to your high school trigonometry, great, go for it. You'll know something about tan and inverse tan, and you can take the rise over the run, divide that, hit it inverse tan, and you'll get the degrees that slope is. Now, I'm not actually going to present that in this video. If you want to do that, that's great. The reason I'm not going to do it is that there is a much easier way and more meaningful way to determine the slope, the gradient of a landscape in degrees. And that's just using pen and paper and a ruler and a protractor. It's the only sort of technical piece of equipment you need. So how do we do that? What's he talking about? So we know our rise and we know our run. Let's grab a piece of graph paper that I just printed off the internet this morning. Pop that there. And we draw it. We actually draw the slope on the graph. So you take a piece of graph paper or any paper, it doesn't have to be graph paper, just graph paper is helpful to get your lines nice and square. You then plot on that piece of paper your rise and your run. Now you need to choose a scale to represent that run and the rise. It has to be the same scale. You can choose whatever scale you like, as long as they're the same. The angle of the slope will come out the same, irrespective of whatever scale you use. So with these numbers, I'm going to choose 1 centimetre equals 100 metres. All right. So along the x-axis, 1 centimetre for 100 metres, for 1,950 metres would be 19.5 centimetres. And then for the y-axis, 140 metres would be 1.4 centimetres. Okay, now you find where those 2 points intersect. So you take your ruler, make sure it's nice and straight, parallel to one of the lines on if you're using graph paper, and then that's where those 2 lines intersect. You then take your ruler again, and from the origin, the bottom left-hand corner, just draw a line up to that point. And there you have your slope. Now you can see it now. That's a visual representation of the slope, which to me is actually a whole lot more meaningful than working out the tangent of a fraction, whatever. You can now see that slope, and you can think about it, and you can actually understand it better of what it might be in reality. If you want to get the angle, then you take your protractor. And my kids have taken my protractor to school because they've lost theirs. So I just had to print one out from the internet. And so you place center of the protractor again in the bottom left-hand corner. Make sure it's parallel to your axis. And then if your protractor was a plastic one and see-through, it'd be easier, but I'm just going to take again my ruler, and from the middle of the protractor, the point, line it up against the line that I've already written. And because it's paper, I can now just do that. And where that line intersects with the protractor, that's how many degrees it is. So it looks like it's about a 4-degree slope. Now, admittedly, if the elevation is not huge, it's going to be a little harder to draw it on the graph, but you should still be able to estimate it this way. And I think this is much easier than trying to use trigonometry to work it out. So there are the different ways of presenting gradient as a percent, as a ratio, and in degrees as well. So hopefully that helps.